So next thing we're do is that we're going to release the sides of our dams, which can be tricky sometimes because of suction, which I'm having a slight issue with at the moment. But there we go. And now we're free. So the ends are going to be exposed. It's going to allow you to take that charge. Okay. Next thing we need to do is put our tray in our box. Okay. And what you're going to do is put the sample side toward the black electrode and leave the open end toward the red electrode. Remember that when we talked about DNA previously, that DNA is negatively charged. So you're going to be running toward the positive end. We want to make sure that the samples are at the negative end, running toward the positive end. Okay? So the way that I always remember that is you're always running toward red. Okay? And that's what our samples are going to need to do. So samples on the negative side, running toward red. Now that we have the tray firmly in the box, we're going to add our buffer. Okay? You want to add it to one of the wells to the side. And this horizontal chamber is also called a submarine chamber because you're going to have the buffer flow over the gel and completely submerge it, like so. Now that you have the gel submersed in the buffer, seeing the wells is going to get pretty tricky. So luckily the samples have dye. Okay, you guys are running dye samples. So we can add those and it'll be able to help. You just want to be very careful when you load the samples not to be too shaky, don't have too much coffee. Make sure that you can steady your hand and not poke through the sides of the wells. So in discussing samples, let's go ahead and get ours mixed up. Okay. So using your micropipetter, you're going to add 10 microliters of your glycerol and deionized water solution. We're going to put this on parafilm and make individual dots, which is going to allow us to make several samples. Okay, you want to be careful not to touch the sides of the tube. So what I've got now is 5 individual glycerol deionized water so that we can go ahead and start with adding your food coloring. Typically you want to have a tip repository for things. I'm going to use this empty flask at the moment and then we'll go back and make sure that we empty that later. Okay. So we're going to start off with the blue food coloring. Make sure I pick one with enough in it. You're going to add this to the drop of deionized water and glycerol. You're going to do the same with all of the samples that you've been given. Make sure that you do switch out a new tip every time that you go in for a new food coloring. You don't want to cross-contaminate. And while we're just working with food coloring this time, it's a good habit to get into, especially when you start working with more important and more expensive samples. Now that we have all of our samples mixed in with the deionized water and glycerol, we are then going to take 10 microliters from this 20 microliter solution, and we are going to add them into our wells. While you guys were waiting for this, you need to make sure that you're taking your 1, 2, 3, 4, 5, or whatever order that you're doing to make sure that you're keeping an eye on your wells. You want to make sure sample 1 goes in well number 1, sample 2 goes in well number 2, and so on and so forth. And that way you're not later questioning how that happened. I would suggest while this is running to take time to draw a map of your gel. All right, everybody ready? Okay. It's not a good one. You want to make sure that you don't have any bubbles. Notice that when I'm drawing the sample up, I'm getting a nice full solid sample. There's no bubbles, there's no open space. When you do that, if you accidentally inject that air into the sample, you're going to end up kind of spilling some of it over to the side. The glycerol that we added is there to weigh the sample down for when you put it into the wells. Don't be concerned if any of the dye kind of comes up top. You want the bulk of that sample to be down in that well. And the glycerol is really what helps it weigh it down. So now that we have all of our samples loaded, you can see I spaced them out and put some others close together. That's just how I wanted to load the wells. Your instructor will give you a direct map, or you can create your own. But once you have them loaded, you do not want to move the horizontal chamber. You want to leave it alone, because when you move it, then you're going to start moving the dyes and you could have sample that comes out. So you want to make sure that your power source was close enough to the box that you aren't going to have to move it in order to run your gel. So now what we're going to do is put the top of our box back on. Remember that you want to make sure you match up the red with the red, okay, and the black with the black. Plug it in and turn it on. What we're going to do is set the voltage for 80. Okay. And you are going to run your sample for about 45 minutes to an hour until the dyes actually start to separate into bands. So now that it's been 45 minutes, we're going to go ahead and cut off our machine. Number one thing that you need to do is make sure that you do turn your machine off and hit stop. If you do not do that, I always like to also turn off the machine and unplug to be safe, because you are dealing with electricity. What we're going to have to do now is take the top back off of our horizontal chamber. So now that I don't want to move it too close, but now that you can see, our samples all started back at the starting line. They all started off together in their wells. And then as the electricity was flowing across the gel, the larger particles are actually staying further back because they're caught in the sieve and they're not able to move very far. The smaller ones are much more advanced. If we let this run for a little bit longer, we might be able to see a more distinct between the bands. As we can guess just from looking, the blue did not move the farthest, therefore the blue must be the heaviest out of all of ours. The yellow moved the farthest, therefore it must be the smallest. And when you look, you can see that the green is actually made out of blue and yellow that have separated quite significantly for you to see. So this is a really neat experiment that you can do to separate different negatively charged molecules based on electricity.